that any instrument with which you are going to study them, because you're not going to observe them directly, right? You're going to put an electron microscope or some kind of, because the instrument is so large and operates at the regular laws of Newton. When you try to measure the momentum or the position of an atom, right, or an electron, you inevitably disturb where it was. In other words, there's no way of observing, which by which they should have said interacting with the atom without disturbing, and I can totally accept that. If you have something that's so tiny that any interaction at our scale, even a minute interaction, a hair going like this, a hair is already several atoms thick, so from the point of view of the atom, a hair is like a huge cylinder that's, oh my God, what's coming at me? That hair is going to disrupt the electron, it doesn't matter what. But then again, we sort of knew that even before the uncertainty principle. When you put a thermometer to measure water or to measure your own body here, the thermometer has its own temperature. So it's going to affect the temperature of whatever you're measuring. So what you do is you put the thermometer, you wait, right? Every time you put a thermometer, you have to wait a minute until the two come into equilibrium, until this stops disturbing this, and this that has a much higher temperature equalizes that with the thermometer, and then you take it out and you see the temperature. In other words, any measurement or any intervention in reality to obtain data from it is an interaction. And because it's an interaction, it's going to disrupt that reality a little, in the case of a thermometer, a lot in the case of an electron, and that is an important methodological issue. How do you correct for that distortion? Otherwise you cannot obtain exact measurements. But unfortunately, Heisenberg, being a positivist, positivists are Kantian, that he, instead of saying interaction, he said observation, as if it was the same thing. And so he made us believe that it was the consciousness of the observer, the consciousness, as if it was a psychokinesis or something, that was disturbing the atom. And that, once it became published in the Zen and the Art of the Quantum, or I can't remember right now what the name of the book was, like a 60s book, in which, they try to put Zen with quantum mechanics. Of course, the consciousness, the Buddha consciousness of the atom, it became a New Age thing that became completely blown out of proportion, when in reality, it does encapsulate a very real truth. Measurement implies interaction. It doesn't matter how you cut it. And interactions disrupt what you're measuring. So, measurement methods need to have a way to compensate for that distortion. If they don't have it, then you're not getting accurate measurements at all. In the case of single electrons, that is a major deal, because you cannot measure the position or momentum at the same time. If you measure one, you disturb the other. If you measure the other, you disturb the first. And so you have that uncertainty that Heisenberg gave his name to. I'll get back to you.
What you described just as observation and interaction with matter, does it extend to waves, to light? Because I'm thinking about, and this is totally pseudoscience, I don't really know what I'm saying, but...
No, absolutely. When I say matter, I mean matter and energy. Right? Mm-hmm. So electromagnetic fields, radio waves, television broadcasts, wireless internet is every bit as material as the internet that comes through a cable that you can touch and bite. Right? Just because they are invisible to us doesn't mean that they are less material. Right? They are still made out of energy.
And you gave concrete examples for then our interaction with matter, separating it or distinguishing it from observation. How would you give a concrete example of our interaction with light by observing it? How is that actually an interaction?
Well, for one thing, all the light that you're getting is light that is right now bounced from objects, right? But if we were at night and you were not getting any light bounce for objects, you had to light up either a candle or a flashing light. In which ways you're shining light on things and bouncing it, you're interacting with it, right? So normally we don't need to interact with things because the sun is doing the interaction first. It's shining over everything, it's bouncing light that's reaching our senses, and we're not even aware of that, so we just take it for granted. The moment the lights go out, you don't take it for granted anymore. You know you have to produce your own light and bounce it off objects, and then read that bounce back light as, oh, there's a table in front of me, or there's a couch in front of me, I should walk around it. Right? Everything implies an interaction, even if the interaction is mediated by something else that's doing the interacting, in this case the sun. Right?
And I guess I was thinking of that, I don't completely remember it, distinguishing the fact that light is both wave and particle, and something about it only being a particle when it's observed. I don't know if I completely followed.
Yeah, no, that's another myth. That's another myth that comes back again with positivists. They want to introduce that myth. No, light is can both act as a particle and as a wave, and as an objective phenomenon that has nothing to do with there being a human being in the place, and has to do more with how many photons of light are you producing at the same time. The moment photons are particles that tend to group together immediately and form a field. So when you have 200 photons, they immediately join together into a field. But if you manage to isolate one photon at a time, that photon will start acting as a particle. It has to be done in a laboratory, because you can never in nature see a single photon. Hey, you see a single photon? In nature you always see fields. But in a laboratory you can create those special artificial conditions where you can create a single photon, and then the paradox immediately begins to act, right? And of course technologically too, because it's the difference between photography and holography. In a photograph, the lens separates the photons in a way. It gets the whole beam of light, but the lens, by focusing it on a plane, or where the sensitive piece of paper is separating every photon, and in a way saying this photon, say, is black and white, this photon is black, this photon is white, this photon has a medium intensity, which is gray, and then it creates an exact replica of what's in front of it by mapping via a lens every photon and its intensity. Holography, which is lensless, doesn't have any lenses, does it in a completely different way. That's why it looks so paradoxical. When you create a hologram, you shine a laser on something, but the same laser that went into you, I'm making a hologram of you, right? I'm shining a laser to you, but I'm also dividing the laser into the laser before it hit him, and this guy now has the information of the laser before was hit. And then I make the two cross, they form a diffraction pattern, and that is what eventually ends up in the form of a hologram. But a hologram, unlike a photograph, a photograph, because everything is points, you cut a piece of the holograph and you just get a piece of the photograph. If you cut the head, you just get the head. But in a hologram, if you cut a small piece of the hologram, you get the whole hologram, only with much less detail. You cut a tiny little piece of the hologram and you still get the whole, only now it's totally blurry. And that is freaky, because you're thinking photography. So that's light behaving as a particle and as a wave at the same time, depending on two technological apparatuses, and it does give very, very different results. You had a question there, I'm sorry.
Yeah, I guess everybody wants to take a break, but and I know you want to talk about economics later.
Well, that's tomorrow.
Yeah, okay, tomorrow. But I keep thinking that the reason that Kantian, Kant was not so much more successful is because it fits well with private property and with the kind of sense of, like with the declarative sentence, it is a commodity, or can be a commodity, is the one discrete thing that you can claim is your own, and then you can invest it. Proprietary.
It's interesting. I never heard that one. Marx's take on the triumph of Kant.
Yeah. Well, because we're talking about materialism, right?
That's right.